starting for the CO10, which next year in algebra, we're going to cover this a second time. It's just that important. Next year it's a PO. This year it's just a CO. But we're talking about the order of operations, kind of the math law that dictates how an equation is solved. Okay? Who's got a really good movie voice? You know how it's always like really like, you know, deep and mysterious? Liam? You've been called out. Do you agree? Do you have a good movie voice?
No.
Yes.
Oh, Sawyer. What?
Sawyer? Cam, yours is very baritone-like. No? Okay. Well, fine then. Imagine a world without rules for solving equations. Right? That's going to hook you in. Okay? Consider what we have here. 3 plus 4 times 7 equals 49. And 3 plus 4 times 7 equals 31. Okay? It would be a problem.
What?
Right. It would be a problem if the same equation equaled two different things. Okay? Because someone explain to me how you could get 49 as an answer from 3 plus 4 times 7. How could you see coming up with 49 as a possible answer, Liam?
You do 3 plus 4, you get 7, and then you multiply it by 7, and you get 49.
Right. If you add 3 and 4 first, you get 7, and then multiply by 7. 7 times 7 is 49. How could you conceivably get 31? From the same equation, how do you see how 31 could be a possible solution?
You do 4 times 7 first.
Yeah, if you take 4 times 7 first, you get 28, and then 3 plus 28 equals 31. That's a problem, right? We don't want the same calculation to give two different things. Thinking like medicine, you know, if you are a doctor or a nurse or a pharmacist and you're calculating how much medicine a person should get for their illness, like that's got to be pretty accurate. You don't want to give a young baby too much medicine or too little medicine, right? It has to be accurate. And so that's why we have the order of operations. Who knows what the correct answer should be here? Madeline. Why? Using PERMDAS, using the order of operations, it says we need to multiply before we add. Okay? And so following this order of operations is super important. Layla, you had your hand up too. What? 31? Okay? Now, you will not be able to use a calculator on this objective on the test, because your calculator always does the correct order of operations for you. It's programmed to do it. I want to make sure that you know how. So we're going to start by writing down what the order of operations is, and then practice a little bit, then I have a song to sing for you. It's going to be a great day here. So for starters, the order of operations is P, which stands for parentheses.
I don't have to write it though.
Yes, you do need to write it. You do need to write it. Now, parentheses aren't an operation, right? You can't parenthesize something, like you can add something or multiply something. Parentheses are there to, if you do want to change the order of operations, that's what you would use. Okay? So they're out in front, they're done first, they aren't actually an operation, but they do allow you to change the order if you wanted to. The next one, E. What does E stand for? Exponents. Job well done. Exponents. The next letter is R, which stands for radicals or roots. When you talk about square roots, okay, radicals, roots. Then comes M. M, of course, stands for multiplication.
Oh, I forgot the M.
D stands for division. A stands for addition. And S stands for subtraction. Okay? And there's a method to the madness here, right? Who remembers talking about what the relationship between like addition and subtraction is? Or multiplication and division? Or exponents and roots? Like, what's up with that? What's the relationship between addition and subtraction? We'll start with that one.
Are they like the opposite?
They're opposites, okay? That's how the order of operations is kind of set up. There's like 3 different layers here, you know? addition and subtraction are opposite, they're like together, okay? Multiplication, division are opposite, they're together as well. If you multiply something by 5 and then divide by 5, you're going to get right back to where you were, right? If you add 10 to something and then subtract 10, you're right back to where you were. They're opposites. Exponents and radicals work the same way. You're probably least familiar with exponents and roots just because you haven't used them a whole lot. But if we square something, I'll kind of do it up over here. If we square, say, 3, what do we get? What is 3 squared?
6.
Not 6. It's not the same as 3 times 2. That's where it gets a little bit tricky. 9, right? 3 squared means 3 times itself. Okay, there are 2 3's being multiplied together. So 3 times 3 is 9. If we want to get back to 3, if we take the root of 9, what that's asking is what number times itself equals 9? And that would be 3, right? So if you square something, to undo that, you take the root of it. And that's why exponents and radicals are opposites as well. Parentheses, they don't have an opposite, because like I said, they're not an operation. You can't parenthesize something, right? So, the other caveat to this is that if you only have addition and subtraction in an equation, do you have to do the addition first? No. What direction do you solve it in? Well, you'd work from left to right. Left to right. Do we have anything like that in here? I'm not sure we do. Perhaps not. But they are opposites. Okay? Let's just solve these things. It says evaluate each expression and show all your steps. Operations on the same level of a PERMDAS can be done in the same step. Check your answer with a calculator. So this is important when you do your homework. You may check your answer, but I don't want you finding your answer. Okay? You won't have a calculator on the test, so I want you to practice doing these without one here. But 12 plus 4 times 3, what are we doing first? According to the order of operations, what is done first? 12 plus 4 or the 4 times 3? Brandon? The 4 times 3. So I want you to do on your page, and we're going to do the exact same thing here. I want you to underline the 4 times 3 and then rewrite the expression with that part solved. So 4 times 3 is 12. So instead of 12 plus 4 times 3, we're writing 12 plus 12. Okay? And then what is 12 plus 12? 24. And so you'd write your answer down below just like that. So when it says show every step, that's why I want you to do it. Underline what you're doing and then rewrite the expression with that thing done. The next one, 3 divided by 3 minus 2. What's being done first? Madeline? There are no parentheses here. Yes, the division. 3 divided by 3, which equals? 1.
Oh, wait.
3 divided by 3 is 1, right? And then subtract 2 from that. What's 1 minus 2?
Negative.
Negative 1. That would be your answer here. Okay. Let's go to one that's a little more challenging. Perhaps that middle one in the bottom row, that 6 minus, in parentheses, 4 times 2 squared divided by 3. That's got a lot going on there. Wow. What do we got to do first?
4 plus 2.
Jimena.
3 plus 2.
We're doing this one here. The middle one in the bottom row.
Do the 4 plus 2.
Yes, you were right. You were talking about what we do in the, yes, the 3 plus 2 would be correct there, but in that one, parentheses do come first, okay? So within the parentheses, we have that 4 plus 2. That gives us 6. So now we're going to rewrite this to be 6 minus 6, because that's what was in the parentheses. That's being squared, and then divided by 3. What's done next?
6 divided by 3.
Not the divided by 3. We have subtraction,
6.
we have an exponent,
Square.
and we have division.
Oh, the exponent.
The exponent's done next, yeah. E is on a level above division, right? So 6 squared, what's that? 6 times 6?
36.
36, not 12, right? It's not the same as 6 times 2. And I wrote 12, oh my goodness. 36 and then divided by 3. What comes next?
36 divided.
Next comes the division, right? Division's on a level above the subtraction, so division comes next. Negative 36 divided by 3. I'm going to have to write it up above because I ran on a space here. We get 6 minus 12 is your next line there. Negative 36 divided by 3 is a negative 12, so 6 minus 12. And finally, what is 6 minus 12? Negative 6. So that should be your answer. So you're just taking it step by step. Don't try and solve the whole thing at once. Just take it step by step. Okay? Another one you want to talk about potentially? Or is there one that we've done that still is a little bit kind of puzzling? Come on.
The last one.
The last one. 11 plus 3 divided by 11 minus 7. So we have two sets of parentheses, and then division in between them. What are we doing first? Rui.
11 plus 3.
Yeah. And can we do this other set of parentheses at the same time? Yes. Right? Because we have to do both of them before we divide anyway. So they don't. One doesn't really affect the other. We might as well do them both at once. So 11 plus 3 is 14. And we're dividing that by 11 minus 7, which is 4. Okay? And at this point, you might be thinking, oh my goodness, 14 divided by 4, that doesn't work out evenly. And I can't use a calculator? What am I going to do? Okay? As you get further into the maths, stuff like this is going to happen, where it doesn't work out evenly, and that's okay. Yeah? Do you have a question? Yeah. Okay, so use a calculator for that, right? Which you won't have on the test. So how would you go about this on a test, not having the aid of a calculator, and answering the question?
Are we not having a calculator the entire
I don't think so. Actually, I think it's a no calculator test. No.
Unless you mistakenly put that on the test.
Correct. We've talked about this before. What's another way to write division? This is the division symbol if you're writing something horizontally. How do you write division vertically? As a fraction. That's where our division symbol comes from. Like, we've got a dot, and then a line, and then a dot. That's kind of like what a fraction is. You've got a number, and then a line, and then another number. Okay, this horizontal division symbol kind of looks like a fraction, because you've got something over something else. So we can write 14 divided by 4 as 14 fourths, and then all you have to do is say, is that in simplest form? Or can I simplify 14 fourths?
You can.
You can. What do you have to divide by?
You can divide by 2.
Divide by 2, right? So we divide 14 by 2 and divide 4 by 2, and we end up with 7 halves, which as a decimal does equal 3.5, but you can leave it in fraction form. So without a calculator, you're not actually taking 14 divided by 4, you're writing it as a fraction and then simplifying it down. Okay, so that's kind of nice. That's kind of nice. The second part of this, going down below, it says it's possible for each expression below to equal 30, but not as they are written. Like if I solve this as it's written, I'd have to do 5 times 3 first, because multiplication comes before adding, which is 15, and 5 plus 15 equals 20. However, it is possible for it to equal 30 if I add parentheses, because remember, parentheses change the order of operations. Where would I need to put parentheses in that expression so that it equals 30? Liam?
5 plus 5.
Right. If I put parentheses around 5 plus 5, now I do that first. Because I've changed the order of operations. That's what parentheses do. So 5 plus 5 is 10, and 10 times 3 does equal 30. So you're placing parentheses in the expression to literally change the outcome. You have so much power right now. Parentheses equal power. Okay? Let's do the third one. 4 plus 2 squared minus 6. If I do it as it's written, I have to do the exponent first, which 2 squared is 4. 4 plus 4 is 8. 8 minus 6 is 2. That's not 30. Where can I put parentheses here to change the order of operations so that it will equal 30? Yeah?
The 2, the second half.
Put it around the 2 and the,
The 2 over the 2. The exponent.
like right here?
Yeah.
Well, I have to do that first anyway. Right? If I solve it as it's written, I have to do the exponent first anyway. Adding parentheses around it isn't going to change the order, because that's what is done first anyway. Anyone see it?
Yeah,
What do you do?
4 plus, you put 4 and 2 in parentheses,
Aha!
and then you do that, and then you 6 and 2.
Yeah.
36, and then you minus, subtract that.
Good. If I put parentheses around the 4 plus 2, now I'm saying do that first. Don't just square the 2, square the sum of 4 and 2, which 4 plus 2 is 6, 6 squared is 36, and 36 minus 6 brings me to 30. So it might be a little bit of trial and error, okay? Where can I put parentheses here to make this equation work out to equal 30? And then finally, at the bottom it says write 2 expressions, each with 4 operations from PERMDAS. Any 4, and you can use parentheses, even though they're not an operation, they can count as one of your 4. Make one expression equal 25 and the other equal 100. So 2 expressions using any operations that you want to, but you have to use 4 of them. One expression has to equal 25 when you solve it, and the other one equals 100. Okay? Questions on what you are to do? What's that? The last one? 36 plus 7 times 12 divided by 4. Yeesh. Anyone has tried this one and come up with a solution? Sometimes you just gotta start trying things, right? If I put my parentheses here around the 36 plus 7, that's 43. 43 times 12, that's a big number. That's probably not gonna lead me down the right path here, okay? So, solving this the way it should be, I'd multiply first, and then do the division. So I want to change that. I don't want to multiply first and then do the division. Yeah?
You could do 12 times, or 7 times 12 plus 36 and then divide it.
Okay. So if I put my parentheses around all this here, within the parentheses I do need to multiply first. 7 times 12 is 84. So I get 36 plus 84. Divide by 4. I haven't done the parentheses yet, so I still have to finish that out. 36 plus 84 is 120. And 120 divided by 4 equals 30. Job well done.
Oh,
Okay.
I got that, and I was like, what can equal out?
Good! Yeah. So that's how it equals out. Okay. Questions, comments, concerns, complaints, compliments, congratulations, criticisms on the order of operations. I'm going to reference this going forward a lot because this is kind of like your I don't know, path for math, right? Everywhere around the world, the order of operations is recognized, and that's how we make math a universal language. Okay? Everywhere in the world, this is how equations are solved. Okay. Homework for tomorrow. So you've got this. You also have Khan Academy if you haven't done that. Let's play the number game tomorrow. It's soup's fun. I have a great time, and you are getting better. You're learning more about how to play, and you will get that point soon. In the meantime, though, that's iMath.
Don't forget to like and subscribe.